Hi everybody, let us say this kind of differential equation. Now what you are noticing here is this is Cauchy's linear differential equation, and it is a non-homogeneous equation. We cannot solve these problems like what we have done earlier cases. So this can be done uh, by replacing some of the elements here. So during the process, uh, then we can try to uh, uh, get the ordinary differential equation and try to solve it. Let us see how it goes. Now this is x square y double dash plus 3x y dash minus 4y is equal to 2x square. Now let us try to solve this here. Now this can be written as x square d square into y plus 3x dy minus 4y is equal to 2x square. Fine. Now what you notice here, the common factor here being y. So let us remove that. So I get x square d square plus 3xd minus 4 into y, which is equal to 2x square. Fine. Now this is the simplest form which we have done here, and what we notice here is power 2 and power 1 and 0. So we have to replace this, okay, uh, and we get an ordinary differential equation, and which can be solved in the regular way. So let us see that. Now let us put this as 1 log x is equal to z. So when you remove log, so you get that as x is equal to e to the power of z, what we get. And then afterwards we have to replace x d as d1 and x square d square as d1 into d1 minus 1. Now let us substitute all this which I have mentioned here. So now the equation becomes, that is d1 into d1 minus 1, okay, that is for x square d square, and the next term which is 3 d1, okay, minus y minus 4, okay, don't forget that 4 here, so let me write that once again. So that is 4, and it is multiplied by y. So now we have taken a log x as z, right, and x is equal to e to the power of z. Let us put that. The right hand side, what we have that as 2 into e to the power of z, and this is whole square. So this is what we get. Fine. Now let us try to simplify this further. If I simplify this, I get this as d1 square, okay, and plus 2d1, okay, minus 4 into y. Now this can be written as 2 into e to the power of 2z, right? So now this is our regular differential equation of second order differential equation, and it is non-homogeneous differential equation. Earlier we had the Cauchy's linear differential equation, which has been reduced in this form. So that's what I arrived. Now the regular uh, method, that is finding the auxiliary equation. The auxiliary equation would be again m square, okay, plus 2m minus 4 is equal to 0. So we find the roots, that is m, which is minus 1 plus or minus, this would be square root of 5. So these are the roots. Now once we find this, we can find the complementary function corresponding to that. Okay, so that is yc, which we get. So that would be c1. Now the first root is minus 1 plus root 5 into z. So we have changed into the variable which is z here, plus c2, and this would be e to the power of minus 1 and minus root 5. Okay, so this is multiplied with z. Okay, that is very important. So it is multiplied with z. Now again, to write in the terms y, in terms of x, so that would be, this is yc, would be the c1. Now this would be x to the power of minus 1 plus root 5 and plus c2 x to the power of minus 1 and minus root 5. So this is what we get as the complementary function, that is yc. Let us find what is yp here. So further, let us find what is yp. Yp would be, now this is 2 times e to the power of 2z, so will be divided by, now d1 square plus 2d1 minus 4. Okay, now let us substitute d as 2. So when I substitute d1 as 2, so 2 times e to the power of 2z divided by, this is 4 and this is 4, right? And this will be minus 4. So these two gets cancelled. If I try to simplify this further, I get 1 by 2 times e to the power of 2z. Fine. Now we have to convert this z into x. So let us replace that. So yp would be, that is half of x square, because we have taken x as e to the power of z. So y will be yc plus yp. Fine. Let us look into the next problem. Okay. Now suppose we have another problem of this type, which is x y double dash minus 2 by x into y is equal to x plus 1 by x square. Now again, this is of Cauchy's linear differential equation. Let us again write this in the normal differential equation, and then afterwards find the solution for the differential equation. Now this can be written as, if I take x square, So this is x square throughout. So x square y double dash minus, so this would be 2 into I will take x square x and this will be 2y. Okay, so that is equal to this is x square plus 1 by x. So what we have done is taking x square both the sides, x on both the sides. So if I multiply that, x gets cancelled and get this result. So this, if I rewrite this as x square, this is d square minus 2 into y. What we have done is x square y double dash as x square d square into y. That's what I have done. So this is equal to x square plus x to the power of minus 1. Okay. Let us further try to solve this. Let us put the log x as z, okay, or we can write x as to the power of z, okay, and then again the regular process which we have been doing it. So that is x d is equal to d1, right, and x square d square as d1 into d1 minus 1. Fine. Let us try to solve that by substituting all those elements which we had. So that is d1 into d1 into d1 minus 1. Fine. Minus 2 into y. Now this is e to the power of z and its whole square, okay, plus e to the power of z to the power of minus 1. That's now if I try to simplify this, I get d1 square minus d1 minus 2 into y. Okay. Now this would be e to the power of 2z plus e to the power of minus z. Fine. Now this is an second order differential equation and it is non-homogeneous. So let us find the auxiliary equation corresponding to that. So that is m square minus n minus 2, which is equal to 0. So since it is a quadratic equation, you get the two roots, m as 2 comma minus 1. Okay. Now the complementary function, that is yc, which is c1. Now this would be e to the power of minus z, okay, plus c2 e to the power of 2z. Now again in terms of x, so c1, now this would be x square plus c2, this would be x to the power of minus 1. So we have found the complementary function. Let us find what is particular integral, that is yp. So yp would be, that is e to the power of 2z divided by, this is d1 square minus d1 minus 2. So this is one particular integral what you have to find, and this is another particular integral which you have to find, e to the power of minus z, and this is d1 square minus d1 minus 2. Fine. Now let us put that d1 as 2 for the first term. So when I substitute that, that goes to 0. So let us do that. So e to the power of 2z. So this is 4, and this is 2, and this is 2, right? Plus, now if I put as minus 1 here. So this is 1, and this is plus 1, and this is 2. So this denominator goes to 0. So this denominator goes to 0, and even this denominator also goes to 0. So your function, which is f of d, that is d1 square minus d1 minus 2. So if, since it goes to 0, you have to find the derivative for this. So that is f dash of d. So you get 2 d1 minus 1. Let us put that and multiply z in the numerator. So we get z e to the power of 2z divided by the denominator which we have found just now is 2d1 minus 1. Okay, and even this also has gone to 0, so multiply that with z, and denominator will be 2d1 minus 1. Fine. Now let us substitute d1 as 2 again. Now when we put that d1 as 2, so 2 into 2 minus 1. Okay, and now here what we had as minus 1. Let us substitute that. So that is if I substitute that as 2 into minus 1 and minus 1. So okay, so we arrive into, this is 4 minus 1, that is 1 by 3, and since this is minus, so this is 1 by 3. If I take z outside, which is common, so if I take 1 by 3 also, which is also common, so multiply that, e to the power of 2z minus e to the power of minus z. Okay, now since z, we have replaced that as log x. Okay, so let us write that in terms of x. So this will be x square, and this is x to the power of minus 1. So this is your y. So the final solution is y is equal to yc plus y. So this is the, please look into my videos, okay, and subscribe. Thank you.